Very good morning to all of you.
Good morning, sir.
Am I audible?
Good.
Yes, sir.
Good morning, sir.
Okay.
Good morning, sir.
Welcome back to the session of engineering mechanics. So in the last class, we have started the second chapter. So what we have studied in the last class, we have seen what is equilibrium, what are the conditions of the equilibrium, and from that equilibrium, we have seen Lami's theorem. Okay, what does this Lami's theorem says? Yes, anyone? Anybody can you tell me statement of Lami's theorem? Yes, anybody?
When three concurrent forces keep the body in equilibrium, then each force is proportional to the sine of angle between the other two forces.
Tan of the angle.
No,
Sine
sir,
of the
sine.
साइन सर
But you
Sine
said
म्हणलं.
tan, no?
No, sir, sine म्हणलं.
नहीं उसने साइन ही कहा था सर
Okay. So it states that when three concurrent forces, each word is important here. Three concurrent forces keeps the body in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Okay, F1 divided by sin alpha is equal to F2 divided by sin beta is equal to F3 divided by sin gamma. Okay, this is the statement for the Lami's theorem. You have seen this one also, correct?
Yes, sir.
In this proof, instead of F1, F2, F3, here he has taken PQR. Okay, what are PQR? PQR are the forces. Okay, so and alpha is the angle made by the Q and R, that is opposite to force P, and beta is the angle made by the opposite to Q. Okay, and theta is the angle made by the R opposite to R. Okay, don't worry about the same thing, only notations are different. Okay, he has taken like this. Okay, you have taken this point, limitations of the Lami's theorem in the last class.
Yes, sir.
Yes, sir.
Okay, so I have dictated this point, correct?
Yes, sir.
The theorem is applied only when the body is in equilibrium. Lami's theorem is applicable only when the body is in equilibrium. Then it cannot be applied when the less than 3 or more than 3 concurrent forces are acting on the body. Okay, so whenever there are only 3 forces are applied, then only this theorem is applicable. If it is less than 3 or more than 3 forces are there, then we cannot apply. Then which theorem we have to apply? At that time, we have to apply the composition of forces, sigma fx, sigma fy, that you have to apply. Then it cannot be applied for the parallel force system or non-concurrent forces. If there are 3 forces, but these three forces are non-concurrent, we cannot apply. Okay, there must be concurrent force system. Okay, see, these 3 forces are meeting at this point. Okay, they should be concurrent. Non-concurrent, we cannot apply. Okay, so this one you have taken in the last class. Have you taken equilibrium?
Yes, sir.
Yes, sir.
What is equilibrium? An equilibrium is a force. It is a force equal in magnitude, opposite in direction, and collinear with resultant. Equal in magnitude, opposite in direction, and collinear with resultant. If equilibrium is added to a concurrent system of the forces, then the system will be in equilibrium. Okay, it means I will take a small example for you. Wait. Consider this is it visible? Is it full screen?
Yes, sir.
Yes, sir.
Okay, so this is one body. Okay, so this is a body, and इसके ऊपर there are forces, F1 force, F2 force, okay, F3 force. So ये तीनों का resultant कैसा आएगा? So this is the resultant. Is it correct? This is a resultant. Correct, no?
यस सर
Okay, so what is equilibrium? Equilibrium is a force equal in magnitude, opposite in direction. See, I will take one more force which is opposite to this one. Okay, opposite to this one, but it is R dash. I will take it is R dash. This R dash का magnitude कितना है? This R dash is equal to R only. Magnitude is same, but it is opposite to R. Correct? No? It is opposite to the resultant. Opposite in direction and collinear with resultant. See, this is in this direction, this is in this direction, but are they in collinear? Both are in the same line. Both are in the same line.
Yes, sir.
Yes. This and this r dash is same in magnitude, opposite in direction as that of the resultant, and also collinear with resultant. If equilibrium is added to the concurrent force system, see this is concurrent force system, see इसका line of action ऐसे है, इसका line of action ऐसे है, okay, इसका in case if you take like this, okay, like this, ये तीनों ऐसे में इधर point होते हैं ना, so this is concurrent forces. If equilibrium is added to a concurrent system of forces, then the system will become equilibrium. So if this is a concurrent force system, in this case, if you apply the equilibrium, then this body will become equilibrium. Okay, so suppose if you consider this is the body, okay, so this is one force, this is one force, and this is one force. Okay, इसका line of action ऐसे है, इसका line of action ऐसे है, इसका line of action ऐसे है, ये तीनों का resultant ऐसे आ रहे हैं, resultant. But if you apply the equilibrium, it is in opposite direction, same that of magnitude of resultant, opposite direction, में collinear with resultant. ये r dash if you apply किया तो this body will not move, this will become equilibrium. समझ में आया सभी को what is equilibrium?
Yes, sir.
Yes, sir.
Next, one more is, have you taken this one, law of superposition?
No, sir.
No. Okay. Just you have taken the heading. Okay, just I will explain. Listen to me. The action of given of system of forces, the action of given of system of forces on a rigid body will not change, will not be changed if we add or subtract from them another system of forces in equilibrium. This is called as law of superposition. Okay, what it will tell? So this is body. This is subjected to some forces. Now body is in equilibrium. So consider this is in equilibrium. Equilibrium means is it moving or it is not moving?
Not moving.
It is in
Not
rest condition. So in this case, what he is given, the action of given system of forces on a rigid body will not change. Iska action will not change if we add or if we subtract from them another system of forces in equilibrium. अभी इसके ऊपर I will apply some forces which are in equilibrium, or I will remove some forces. I will remove some forces which are in equilibrium. Is it the state? Is it going to change? इसका state change होता है क्या?
No,
Change होता है
नहीं
क्या?
sir.
No, it will not change. See, initially,
because they are in equilibrium.
yes, it was in equilibrium. So whenever the body is in equilibrium, it is in equilibrium. If you add some external forces which is in equilibrium, okay, or if you remove some equilibrium forces, iska state will not change. It will be in the same condition only. Okay, see once again the definition. Also how it is going to explain. The action of given system of forces on a rigid body will not be changed. Okay, एक body है rigid body, उसके ऊपर एक system of forces है. It will not change when if we add to or if we subtract from them another system of forces in equilibrium. We are removing equilibrium forces or we are adding the equilibrium forces so that iska state will not change. This is called as law of superposition. Is it clear, everyone?
Yes, sir.
Nice. Read on this point. Law of superposition. Law of superposition. Read this statement. The action of the given system of forces, on the rigid body will not be changed. If we add if we add 2 or subtract from them another system of forces in equilibrium this is called as law of superposition. Have you taken?
Yes, sir.
Yes, sir.
Shall I go for the next slide?
Yes,
Yes,
sir.
sir.
Okay. See, all these are important for the 1 mark questions. Okay. So in the multiple choice questions, he will give you the statement and it is which law. Okay. Either option A, law of triangle of forces, law of parallelogram of forces, Newton's third law, law of superposition. I say, okay, all the laws you should remember. Okay. So next one is there are different types of equilibrium. So what are the different types of equilibrium? So in the last class we have seen equilibrium means. So there are stable equilibrium. First one is stable equilibrium. Okay, this is stable equilibrium. What is this stable equilibrium? The body is said to be in equilibrium if it returns back to its original position after it is slightly displaced from its position of a placement and bring back to its original position. Okay, so what it means? So consider this is one concave shape. Okay, this is concave shape है. इसमें एक body है. Okay, this is a cylinder. So when you apply disturb it, अब ऐसे force डालने के बाद this goes like this and it will come back to its original position. Correct? If you apply the force like this, okay, this cylinder will go like this and again it will come back to its original position. It means it is in stable equilibrium. Okay, whenever a body is in equilibrium, first of all it should be in equilibrium. Okay, if we give disturbance to it, okay, it will get disturbed and again it comes back to its original position. If it comes to its original position, then you can call it is in stable equilibrium. See the statement once again. A body is said to be in equilibrium if it returns back to its original position. It returns back to its original position after it is slightly displaced. From its position. Position of placement. Position of placement means पहले किधर था ना उधर ही. Okay, and bring back to its original position. Okay, so एक body को disturbance किया तो it will get disturbance. Again it will come back to its original position. Then that is called as stable equilibrium. Then this is in a concave shaped. Okay, so if the surface is in convex shaped, this is a body. Okay, initially it is in stable condition, so that is equilibrium condition. Now apply small force. I say a force डालने के बाद it will move like this. Whether it will come back to its original position?
No, sir.
So if it is not coming back to its original position, then you can call it is which equilibrium?
Unstable equilibrium.
It is unstable equilibrium. Okay, see the definition goes like this. A body is said to be in equilibrium if it does not return back to its original position. Heals further away after slightly displaced. Heals means moves. Okay, heals moves away after slightly displaced from its original position of rest. Initially, it was in rest position. When you get displaced, it will move away from the original position. It will not come back to its original position. In that condition, you can call it is unstable equilibrium. Okay, so example is a smooth cylinder lying on the convex surface. Convex surface. So, Paleka, what is the example? A smooth cylinder lying on a concave or curved surface. Okay, it is curved surface and it is in the convex surface. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Next, one more, neutral equilibrium. What is this neutral equilibrium? So initially, the surface was curved. Here it is convex. Now, if the surface is straight, so give some force to this body, it will get displaced. And is it comes back to its original position? It will not come back, but it will
No,
get
sir.
its new position. It will get its new position. It is called as neutral equilibrium. See the definition. A body is said to be in neutral equilibrium if it occupies new position, if it occupies new position and remains at rest, either say either aa gaya, it is remains at rest only. Okay, at rest in this position after slight displacement. After slight displacement. Example is a smooth cylinder lying on a horizontal surface. Okay, so what are we getting the differences? Stable में क्या था? The body will come back to its original position. So unstable में क्या था? The body will move away from the original position. Okay, it will not. I don't know whether it will come back to its original stable or not, but it will move like this. Okay, but in the neutral equilibrium, the body will move. The body will move to new. The body will move to new place. Okay, new place, but it is in equilibrium. It will be in equilibrium. Is it clear, everyone?
Yes, sir.
Is
Yes,
there any
sir.
doubt? Is there any doubt?
Yes, sir. No, sir.
Okay. So this points you have to write. Okay. So you just take the screenshot of this one. You have to write it. All of you take the screenshot. Okay. This is work for you. Whenever I'm giving any work or any screenshot, you have to write in your notebook. Okay. These are important for the 1 mark questions.
Okay, sir.
Yes, sir.
Okay. So next one is principle of equilibrium. What is this principle of equilibrium? Though there are many principles of equilibrium, yet following 3 important from the subject point of view. Okay, so what are those following points? We will see. First one is 2-point principle. 2-point principle. What it says? Just check it. As per this principle, if the body is in equilibrium, is acted upon by the 2 forces, then they must be in equilibrium, equal, opposite, and collinear. See the example. This is a one body and it is acted by a one forces. It is acted by 2 forces. This is one force and there is another force. Now this body is subjected to which, how many number of forces?
2.
2. Okay, so what is this 2 principle of principles? 2 force principle says, as per this one, if a body is in equilibrium, now the body is in equilibrium. Okay, it is in equilibrium. It is acted upon 2 forces. So this is, I will take it as F1 force. This is, I will take it as F2 force. Okay, in this 2 force, one of the force is they must be in equilibrium and opposite and collinear. See, this force is in this direction. Okay, this force is in this direction. Okay, so these 2 forces are same in magnitude, opposite in direction, but they are in collinear. Okay, so if a body is in equilibrium acted upon by 2 forces, then these 2 forces must be equal in magnitude, opposite in direction, and collinear. Okay, then what is, so you will understand still better by the next principle, 3 force principle. As per this principle, if a body is in equilibrium and is subjected to how many number of forces? 3 forces.
3.
Then the resultant of any 2 force must be equal, opposite, and collinear with the third force. So if I take same kind of problem forces, okay, So this is a body. Okay, if this body is subjected by three forces, I will consider this one, and this is one, and this is one. I will consider now it is not in equilibrium. So first of all, it should be in equilibrium. So consider this is one. Okay, this body is subjected to three forces. Now, you have to tell me whether is it in equilibrium? Yes, it is in equilibrium. I will take it as F1 force. I will take it as F2 force, and I will take it as F3 force. Now, the resultant of these two forces will pass like this. The resultant of these two forces will pass like this. Is it correct? Correct, no?
Yes,
The
sir.
resultant of
Yes,
F1 and F2 will pass like this. Then this F resultant is exactly as that of your F3. Okay, as that of F3. So this F3 will become resultant. It will become as a result same in magnitude, opposite in direction, but it is in collinear. Okay. Once again, read the statement. Three force principle. So as per this principle, if a body is in equilibrium, if the body is in equilibrium acted by three forces, okay, acted upon by the three forces, then resultant of any two forces, okay, I have taken these two forces, resultant of any two forces must be equal, opposite and collinear with the third forces. Equal, opposite and collinear with the third forces. ये दोनों का resultant क्या है? That is equal in magnitude, opposite in direction and collinear with respect to F3. Okay, so इसमें क्या होता? If the body is in equilibrium acted by the two forces and these two forces are equal in magnitude and opposite to each other and they are collinear. Are you getting?
Yes, sir.
Yes.
Okay.
Yes, sir.
So if I consider one more diagram, okay, if the body, this is one force, okay, one body, this is subjected to another number of forces, okay, this is one force, this is one force, okay, and this is one force, and another, this is one force. Just read the statement, what he is saying. Four forces, इसमें क्या है? As this principle, if a body is in equilibrium, as it is acted by the कितना forces है? Four forces. Okay, four forces. Then the resultant of any two forces must be equal, opposite, and collinear with the resultant of the other two forces. Okay. See here, the resultant of the two forces. I will take this is two F1 force, F2 force. This is F3 force, and this is F4 force. The resultant of F1 and F2 will be like this. Okay. So if you consider resultant of these two force, F3 and F4, if it will be like this. So I will take this is R1, this is R2. So this R1 and R2 are equal in magnitude, opposite in direction, but they are collinear. Are you getting?
Yes, sir.
Okay.
Yes,
So
sir.
I will not instead of like this. So any two forces you can take. I will take like this F2 and F3 force, F2 and F3 force. The resultant of these two forces like this. Okay, yeah, F1 and F4 force. The resultant of these two forces is like this. Okay, they are in collinear like this. So this is R1, this is R2. So this R1 and R2 are same in magnitude, opposite in direction, but they are in collinear. Ultimately, they should be collinear. Then only the body is in equilibrium. Okay, are you getting all of you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So this one you have to take. Okay. You just make the you have to write all these things. Okay. Write down. Principle of equilibrium. Principle of equilibrium. Principle of equilibrium. Okay. Just take the screenshot of this one. Will you read? Afterwards,
Yes,
you have to
sir.
write
Yes,
this
sir.
one. Okay. Can I go for next slide?
Yes.
Yes,
Yes,
sir.
sir.
Screenshot till the end.
Yes,
Yes,
sir.
sir.
Don't keep screenshot as it is. Okay, you have to write this one in your notebook.
Yes, sir. Yes, sir.
So till now, have you taken this one? Limitations you have taken, necessary condition you have taken. Equivalent to it. Okay, we have studied all these things. Okay, from this one we will study some of the problems. All of you read on one problem. Okay, read on this problem. All of you read on this problem. A cylinder. Okay, I will dictate. A sphere. Don't write this one. I will dictate. Problem number 1. A sphere weighing 100 Newton, tied to smooth vertical wall, by a string, as shown in figure. Is it visible? Whiteboard?
Yes,
Yes,
sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
A sphere weighing 100 Newton tied to a smooth vertical wall by a string as shown in figure. Find the tension P. Find the tension T in the string and the reaction from the wall. Reaction from the wall. So there is a one wall. Okay. This is wall and there is a cylinder. And that cylinder is attached to like this. See, you have to bring pro circle. आपको मालूम है pro circle? आपके कंपास के साथ रहते हैं pro circle. ऐसे
Yes, sir.
सर्कल ऐसे रहता है इसके बीच में. ठीक है, ऐसे बड़ा रहता है इसके बीच में और छोटा छोटा सर्कल्स रहते हैं. ऐसे ऐसे छोटा छोटा भी सर्कल्स रहते हैं. It will be small solve. Okay, it will be like this. Okay, it will be like this. Pro circle ऐसे रहता है देखो. You have to bring that pro circle because now in this problem equilibrium में maximum you have to draw the sphere. Okay, like this cylinder. Okay, circle you have to draw. So if you have this pro circle, then it will be easy for you to draw the diagram. सभी के पास है क्या? अभी नहीं होगा.
नहीं, sir.
Okay,
No,
so
sir.
bring this pro circle. Okay, समझ में आया ना कैसे रहता है pro circle?
Yes.
बुक स्टॉल में जाके वो उनको पूछे तो प्रो सर्कल दीजिए ऐसे दे रहता है देखो. I will show the figures also. Okay, this is one cylinder which is attached to a string. I will draw the string also. This is a string attached to a wall. Again, there is a. It is connected to look. This is wall. Okay. This one is given. So this is the figure is given. There is a statement. So first and foremost, what you have to draw? Can you tell me? You have to draw free body diagram. So how to draw this free body diagram? So first you have to draw what you have to draw first in a free body diagram. You have to draw circle, that is cylinder, whatever he has given. No? So that one you have to draw. Okay. So this one is given as it is. First of all, you have to draw the body that should be free from all the forces. Now is it free from all the forces?
Yes, sir.
Yes.
Yes, sir.
So this is free body. Now I want to draw free body diagram. Diagram means I have to show all the forces.
Forces
Active,
active.
reactive forces.
So first force I will take. So this is a string. Okay, string means it is a thread which is connected to the cylinder. It is from the center to like this. It is there. Okay, so it is there. There is a force in the string. So that force is acting in this direction, acting towards the point. Okay, that is away from the point. Always there is a tension in the string. String में tension force रहता है. Tension मतलब the force which is going away from the point. This is your point. A point से away जा रहे हैं ना ये. That's why it is called as tension. If it is towards the point, then it is called as compression. Then what are the other forces? Active and reactive forces.
Weight and normal reaction.
Yes.
And normal
Weight,
weight.
Weight and
how,
normal.
how it is acting weight? Weight is acting downward or
Downward
upward?
direction.
Downward
Downward.
direction.
Downward.
So the weight I will consider. So from this point or two, so it is acting downward. This is weight. Again, is there any other force? Is there any other force?
Normal reaction from
Yes.
ground.
Yes. Where is the normal reaction? At contact surfaces. Where is the contact surface? This is the contact surface. Wall. This cylinder is attaching to the wall. Correct. There is a reactive reaction. This is a reaction. Are you getting?
Yes, sir.
So initially there is a string. Initially there is a string. String में ऐसे जा रहे force. Okay. Then weight is acting downward. Weight is acting downward. That is weight. I will take it as weight. And there is a reaction. That is R. I will take. Is it clear, everyone?
Yes, sir.
Okay. In the figure he has given this is 15 degree. He has given already. In the figure he has given already. Okay. If this is in 15 degree, then what about this angle? What about this angle? How much is this angle? So this total कितना रहने का?
180.
Okay.
180.
Okay. Total angle is in a triangle. In a
75.
triangle, it should be total is I will take it as theta 1 plus theta 2 plus theta 3. Theta 3. That is should be equal to 180 रहने का. Okay. This is already 90. So this one I will take it as theta. Okay. This is already 50. So theta 1 is already 90 high. Theta 2 कितना है? Already it is 15 degree high. So I want theta. Theta 3 is theta. So that is equal to 1. You have to find out. That is this theta is equal to this is 90 minus 15. Is it correct? That is equal to
Yes,
75.
sir.
75 degree. Is it correct? Is it correct?
Yes.
So I will write it is.
Yes.
I will write it in another fashion. Okay. I will take it as theta. Okay. I will take here only. This is theta. Okay. This theta is equal to that is this theta plus this 15. दोनों मिलकर 90 रहने का ना. So 90 minus 15 degree. So that theta is equal to how much it is?
75. 75.
75. Okay, this is 75. So again, I will write one more diagram. So in the Lami's theorem, if you want to apply the Lami's theorem, all the forces should be going away from each other. Okay. So how I will write it is, I will draw the same diagram. I will draw the same diagram. I will draw the same diagram. Just I am showing the forces away from each other. So here the first one. In the first case, the force is tension force is going away from each other. Correct, it is. Then the second force. The second force is that is downward force. Okay, downward force, it is correct. Now whatever this force is coming, this will come and this will go like this reaction, correct? No,
Line
so
of action.
line of action. So which law it is? See, I am drawing like this. Which law it is? Law of transmissibility law. Very good, very good. Law of transmissibility. What does it says? Whenever you draw, if you want to remove this force, you can draw, the effect will not be changed. If you replace the force by, if you can apply the force in anywhere along the line of action of force. Okay, so this is the line of action of force. I will remove this force or I will apply like this, so it will not change, correct? No, so now you can mark it. So what is this force? This is tension. What is this one? This is reaction. What is this one? This is W. Okay, what is asked in the problem? Find the tension in the tension T in the string and reaction from the wall. It means R you have to find out, you have to find out T. Okay, now tell me, what is the angle between these two? What is the angle between these two? 90 degree, everyone. Okay, so this one is, it is 90 degree. This one is 90 degree. So this is R. Now I want to find out this angle, and also I have to find out this angle. Okay, see, now initially this is how much? Theta. This theta, this plus 90, is it correct? This angle is equal to this total angle. I need to find out this total angle is equal to, initially it is 90 degree, 90 plus theta, is it correct? This is equal to 90 plus theta. Huh?
Yes.
So 90, so I will take it is,
Yes,
so
sir.
this is equal to, I will take it is theta 1. This is, I will take it is theta 2. So this one I will take it is theta 3. So how to find out theta 3? Theta 3 is equal to 90 plus degree plus theta. Is it correct? I will take, instead of theta, I will write 15 degree directly. How much it is? It is 75. 75.
165.
That is 165. This theta 2 will become 165. Is it clear, everyone? 165 kaise aa gaya? That is angle between W and T. Angle between W and T. So this is W, this is T. So how much it is? इधर से इधर कितना है? 90 है. 90 plus theta. Theta कितना है? Theta कितना था पहले?
75.
75 था. Okay. So this is theta, and now you have calculated. That is theta 3. Okay. Next I want to find out the theta 2. How to find out theta 2? Yes. Total कितना है?
360
Total 360.
minus.
Okay. Yes. Total is 360. So I want to find out theta 2. Theta 2 is equal to, total is 360 degree minus theta 1. Theta 1 कितना है? 90 degree. Okay. Minus theta 3 कितना है?
165.
165. So calculate how much is the theta 2? Calculate.
105.
105.
105.
Okay. So are you getting all of you? Theta 1, theta 2, theta 3.
Yes, sir.
किसी को
Yes,
डाउट
sir.
है क्या? Theta 1, theta 2, theta 3. Yes, if you have any doubt, you can ask me. Okay. Now apply. So first you have to find out. Okay. That is to find. What you have to find out? What you have to find out? That is
Theta 1,
R.
theta 2, theta 3.
R you have to find out. Okay. Your aim to find means your aim.
T.
R you have to find out. Next also I have to find out T. Okay. Next solution. So solution you have to write theta. Okay. आपको समझ में आने के लिए मैंने लिख रहे theta. So this is figure 1 I will take. So this is figure 2 I will take. Theta angle made by R and T. Okay, from figure 2, correct? Then you can calculate theta 1, theta 2, theta 3. Next from figure 2, figure 3 na? Okay, from figure 3, theta 1 is equal to how much it is? 90 degree. Okay, then you have to write theta 3. Okay, theta 3 is equal to how much it is? Theta 3, that is
165.
that is 90 plus 75, that is equal to 165. Okay, next theta 2 is equal to 360 minus 90 minus 90 minus 165 is equal to 105. Is it clear, all of you? Theta 1, theta 2, theta 3.
Yes, sir.
Okay. Now apply which law? Apply sine rule. Sine rule. Okay. What does it sine rule says? Apply. So I will take T. First I will take T. T upon, tell me, T upon sine of angle between other two forces. What are the other two forces? R and W. How much it is?
90.
90. Okay. Are you getting? Next, this is equal to another force. I will take this one. Okay. Okay. You can take anything. R is the force. Then angle between the other two forces. How much are the other two forces?
165.
Sine of 165. This is equal to, so the third force is W. Okay. W divided by, what is the sine of other two force?
105.
105.
Theta 2 is equal to 105. 105. Okay. That is theta 2 is equal to 105. Are you getting how to write this? How to apply the sine rule?
Yes, sir.
Okay.
Yes,
Then.
sir.
Now what you have to consider? You have to do, you consider any two points. Consider any 2 points. Any two equations. Consider first time, what is known here? So in order to apply the that is Lami's theorem, one force should be known, correct? One force should be known. Which force is known here? R, is it known? R,
Wait.
you don't know. T also I don't know, but we know the value of W. Weight is known.
W.
Okay, so consider first and third. T divided by sine of 90 is equal to W divided by sine of 105. 105. So now T is equal to, what is the value of W in the problem? It is 100 Newton. So W is 100 divided by sine of 105 multiplied by sine 90. Yes, calculate the value of T. Just calculate.
सर 270 आया सर.
T is equal to 270.
हाँ सर.
Check it once again. That is 100 divided by sine of 105.
Sir, 104.
Yes, correct. How much it is? 10?
103.
103.50.
Yes, correct. 103 point correct.
Yes, sir. 103.
Yes, wait a minute.
Point 50.
एक मिनट. One 103 is correct. Wait a minute. 103.52.
Yes.
Yes sir.
Yes, this is correct answer. 103.52. Next again, consider second and third one. Second and third equation. This is second one, that is R divided by sine of, how much it is? 165. Sine of 165. Sine of 165 is equal to W divided by sine of 105. So here R value I need to find it. R is equal to, how much is W? It is 100 divided by sine of 105 is equal to sine of 165. Let's calculate now. R is equal to, what is the value?
$103.29.
103.29. Same answer you are getting. No, check it once again.
26.79.
Yes, correct.
Yes, sir.
26.79. 26.7.
Yes sir, correct.
Newton. Okay, so now finally you have to write the answers. So how to write the answers? I will write it in the next page. So just result you have to write. Okay. Result. What is asked? That is reaction. R is equal to and T is equal to. This much you have to write. So you have to keep it in box. Is it clear, everyone? So what all we have done?
Yes.
So in the figure, diagram will be given. Okay, this angle will be given. So you should know first free body. You have to draw the body and you have to apply the free body diagram. That is all the forces. And there are theta. Okay, values. You have to calculate theta also. Okay. So after calculation theta, apply the sine rule. Sine rule apply karke. So which point is asked? That point you have to calculate. Okay, write down all of you. All of you write down. Neatly you have to write down. Roll number 12. 11 is present. 12, 12, 13. 12, 13. 16. 19. 22. 28. 56. 64. Okay, absent numbers 12, 13, 16, 19, 22, 28, 56, 64.
सर
Yes, tell me.
सर ये हमारा पहला प्रॉब्लम है ना सेकंड चैप्टर का.
Yes, first problem.
यस यस.
सर हे कसं आयडेंटिफाय करायचं लामी सेव्हरिनचा प्रॉब्लेम आहे कारण ते इक्विलिब्रियम मध्ये आहे असं दिलं नाही ना प्रॉब्लेम मध्ये.
क्या बोले? हिंदी में बोले?
कैसे आइडेंटिफाई करे कि ये लामी थ्योरम का प्रॉब्लम है.
हाँ हाँ, okay, good, very good
क्योंकि
question.
प्रॉब्लम ये दिया नहीं कि इट इज इन इक्विलिब्रियम.
हाँ हाँ, okay, 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 good problem, good question. Okay, how to identify this problem? Okay, इधर इक्विलिब्रियम है ऐसे नहीं दिया. Okay, correct ना? So ये लेमिस थ्योरम में अप्लाई करने का कैसे समझ में आ गया? See, this is a cylinder. Okay, ये एक स्ट्रिंग को अटैच कर दिया. Now is it moving? This body, is it moving or is it is in stable?
Stable.
First of all, it is unstable, it is not moving. Next, इसका free body diagram निकालने के बाद कितना forces है? कितना forces है? Three forces. And these three forces are concurrent or non-concurrent?
Concurrent.
So that's why I am applying Lami's theorem. In case ये 3 के बदली ओके 4 फोर्सेस है तो 4 फोर्सेस है तो ओके और 5 फोर्सेस है तो I cannot apply Lami's theorem. If there is only 2 forces I cannot apply Lami's theorem. In that condition कौन सा theorem apply करने का? Your composition of forces sigma fx sigma fy वो apply करने का. ठीक है, समझ में आया?
Yes, sir.
Yes,
हाँ,
sir.
so we'll take next one more problem in which there is one body which is subject to 3 forces. उधर क्या इतना कौन सा थ्योरम अप्लाई करने का? उधर लैमिस थ्योरम अप्लाई करने का. और एक बॉडी है उसमें 4 फोर्सेस है बट is it possible to apply the Lami's theorem? 4 forces है तो
No,
No, sir.
no, we cannot apply the
No,
Lami's
sir.
theorem. We cannot apply. In that condition
Composition
we have to
of
go for composition of forces.
composition of forces.
Okay, that is sigma fx apply करने का, sigma fy apply करने का. There are 2 equations and there will be 2 unknowns. You can find out the value of unknown forces. Okay, so in this condition tell me.
इसका मतलब 3 जब भी 3 फोर्सेस होंगे तब हम लैमिस थ्योरी
Yes,
अप्लाई करेंगे.
yes, whenever there are 3 forces we have to
And it
apply.
is equilibrium.
But there should be a point, remember there should be only 2 unknowns. 3 forces, there should be only 2 unknowns रहने का. Okay, so इधर देखो, इधर first term, second term, third term है. ये in 3 terms में okay there should be only 2 unknowns. Okay, in case तीनों unknown नहीं तो we cannot apply.
सर आपने कंडीशंस में बताया ना सर ये.
There should be only 3 forces and among 3 2 forces should be known or 2 angles should be known, 1 force should be known. अभी देखो इनमें से any 2 angles should be known and any 1 force should be known. ऐसे तो we can apply directly. Correct ना?
यस सर.
3 इधर
Yes, sir.
कितना force है? There are 3 forces. कितने angles है? There are 3 angles. Okay, so we can consider first 2 forces or second 2 forces or first and third term. Any 2 terms you have to consider and you have to solve. But there should be unknown 2 forces only. One should be purely known. Okay, ये weight and इसका angle पता रहने का. ये purely पता है तो we can find out the other one. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay. Just I wanted to discuss some people in the non-concurrent forces. See, this is a diagram. Okay, just a minute, I will take. Some people are facing problems. Okay, so this is one coordinates. So this is one force is like going like this, and another force is going like this. Another force is going like this. Okay, another force is going like this. Another force is going like this. Another force is going like this. So which one will you apply here? Which force will you apply? Which composition? So how to find out the resultant of these forces? How to find out?
Composition of forces.
Composition.
Composition of
Okay.
forces.
That is sigma fx and
Sigma
sigma fy.
Sigma
Fy.
Fy.
So some people
R
are
is equal.
they don't know how to apply the sigma fx. उधर एक डैम प्रॉब्लम दिया था ना मैंने. So ऐसे डैम का प्रॉब्लम था. इसमें now इधर एक फोर्स है, इधर एक फोर्स है. Okay, now there is another force. Okay, ऐसा है. So इसका एंगल पता है. This is purely vertical, this is purely horizontal. I have taken sigma fx. Okay, so I have applied sigma fx equal to this is f1, f2, and if it is f3, and this is theta. So sigma fx क्या क्या आता है? Is it concurrent or non-concurrent?
Non-concurrent.
Okay. So this is purely horizontal. I have taken f1. Okay, this is purely vertical. Is it producing any horizontal component? No.
No, sir.
This is it will produce. Is it positive or negative? इसका component एक downward रहता है, एक negative direction में रहता है. So minus
Negative.
f3 cos theta. Okay. So I have solved this one problem. Still students are asking, so how to write the fx? It means you are not understood. So मैंने video upload करते ना. If you have any doubt, you just go through the video. Okay, once again you have to go through the video. क्यों अप्लाई किया मतलब it is basic. Okay, second और third video lecture में मैंने बोल दिया था. Why sigma fx कैसे find out करने का? Whenever there is an inclined force, you have to resolve sigma fx and sigma fy resolve करने का. So if this is a resolution, this will fx point and this is fy point. So this is fx, this is fy. Fx equal to how much? If this is a f force, this is theta, this is equal to f cos theta,
Cos
and this
theta.
is
Yep.
f
Sin
And
theta.
sin theta.
theta. So when to take positive, when to take negative, there is again confusion in the students. See, whenever you are talking about a sigma fx means what? The
Left hand side.
component of force f along horizontal direction, I told, correct? Is it moving in a positive direction or not? If it is moving in positive
Negative
x-axis, right hand side में move हो रहा तो this is positive. If it is moving in negative direction, okay, that is left hand direction, then it is negative.
Negative.
Then what? Fy. Fy means what? It is force which is moving along vertical direction. Vertical may be upward direction or maybe
Upward or
downward.
downward?
Downward.
So this is upward I thought, that is I have taken convention positive. So downward I thought negative.
Negative.
उसमें क्या है? Okay, it means whenever I am explaining the class, you may not be attentive. So if you have any doubt, you have to just go through the video. Once again, you have to go through. See here, why I have taken positive f1? Because it is moving in positive direction. So here I have taken f minus because it is moving in this direction, negative direction. So its component क्या है? X component f3 cos theta. So if I want to write fy, fy means this is f1 is moving horizontal direction. Is it producing any vertical component? No, it will not move.
No, sir.
Because what is the formula? F1 cos of sin
Theta.
vertical direction, it is
Sin.
sin theta. So theta का angle कितना रहता है इधर? तो horizontal में it is 0. 0 है तो this entire it is 0. That's why it will not move. This F2 force moving in downward direction. Downward means minus. Then this F3 force, its component is moving in downward direction. That is also minus F3 sin theta 3. What is wrong here? And some students are asking whether the answer is correct or not. Assignment का answer मैं check नहीं करता अभी. You have to solve your own and you have to upload in the Google sheet. Then only I will check the answers. मेरे को फोटो निकल के भेजे तो मैं कैसे जाऊंगा? There are 60 students. 60 students को फोटो check करके बैठना है क्या? No, whenever I have given assignment, you have to solve your own. Answer check है कि नहीं मैंने बाद में check देखेंगे. एक बार submit होने के बाद I will check. Okay. First you have to solve all those problems. Whether those problems are difficult है क्या problems?
No, sir.
No. Whatever I have solved, basic concept के ऊपर ही है वो सारे problems. Just the dam का problem है. Instead of here, I have taken somewhere. Instead of here, I have taken somewhere. Just there is a change in magnitude. बरोबर? And some problems are same as it is.
सर असाइनमेंट का लिंक टीचिंग डायरी में
हाँ टीचिंग डायरी में अपलोड किया बट देयर इज असाइनमेंट 1 एंड असाइनमेंट 2 ओके ऐसे क्रिएट हो गया वो मैंने चेक करके देखते वो ओनली असाइनमेंट 1 यू हैव टू सबमिट ठीक है do wait today I will upload that is I will make a correction and you can upload it. Have you solved all the questions? कोई सॉल्व किया है क्या?
नो सर.
Okay take your own time.
No, sir. 10 अभी 2 रह गए अभी.
Okay ठीक है आराम से सॉल्व करिए हाँ नो प्रॉब्लम.
सर लीस्ट डिस्टेंस फ्रॉम ए मतलब क्या निकलना है उसमें?
Least distance from A. It means देखो this is one problem. Okay, this is a point. Okay, this is a point A. Okay, this is a point. The force is here, passing like this. Passing. The least distance means perpendicular distance from this point to this point. So if you consider this is body. Okay, so there is a point about moment about A find out कर रहे हैं. Moment about A find out करने का. So the force is moving like this. Where it is least? When there is a perpendicular distance है ना, this is the least distance. So if you take this, is it least? इधर से इधर लिए तो is it least? नहीं ना. The perpendicular distance itself is the least distance. कौन सा problem था वो?
7. Question number 10.
What is that question? 7 problem है ना वो?
Assignment question में.
Okay, उसमें problem है क्या? तेरी है.
Problem है.
Least distance पूछा ना. Least distance is you have to find out the d value. D. How to find out the d? Summation of moment about divided by resultant. D. And if there is intercept x and y, you have to find out. Okay.
Okay, sir.
Any other doubt?
Yes, sir.
Is it clear, everyone?
Yes, sir.
Okay. So
Sir.
we'll stop now here. So remaining things we'll take in the next class. Okay, everyone?
Yes, sir.
Okay. Thank you.